Good evening and welcome to the Jim Fisher Memorial Digital Network Association's inaugural webinar. I'm Steve Davidson, K3FZT, and I'd like to take a moment to tell you about Jim Fisher. Jim was a phenomenon. His call sign, AJ3DI, described him as who he was, a Jedi. He made fabulous contributions to hobbyist computing and amateur radio in the Delaware Valley in his too short life. He initiated the development of the Arden Mesh network in the greater Delaware Valley. And it's for that reason that 8 of us came together as managers to create the Jim Fisher Memorial Digital Network Association. Because Jim was about participation, not about hierarchy. Let me turn the webinar over to my team member, Bill, WB3CQK, who will serve as moderator.
Thanks, Steve. So I hope everyone is able to hear us. If anyone's having trouble, I see there's a couple of folks who seem to be having an issue joining with the web browser. So we'll see if there's anything we can do in a minute to help that. If there's hopefully the audio is at the right level. If anybody's having any trouble there, please let us know in the chat. Okay, it looks like everything's good. All right, I'm going to hand it back to Steve. I think if you should be able to see my email address at the association, so it's wb3ckq@jfmdna.org. If you want some follow-up or if you have some additional questions that you'd like to put in a little bit more full-length questions, please send them to that email address. And again, any questions you have about we're going to let Steve N8GNJ perform his presentation, but please, throughout the presentation, as you think about the questions, go ahead and submit them in the window, and during the question section, we'll relay them to Steve. So I'm going to hand it back to Steve, K3FZT, my partner in crime here with setting this up, and one of the people who was instrumental in getting Steve Stroh to come and talk to us this evening. I think you'll find that the presentation is going to be really interesting, but I'm going to let Steve do the introductions of Steve.
Well, thank you, Bill. And welcome again. I've been part of the team producing this webinar, and Steve Stroh asked me to introduce him. I'm proud and happy to do so. When I first came across Zero Retries, issue number 18, back in November 2021, I felt as though I'd been struck by lightning. Here was a fella who was reading my mind, yet he was from an advanced civilization and knew so much more about everything in radio in data communication than I had even imagined. Each issue of Zero Retries brought new ways of thinking about radio communication and its growing nexus with digital technologies and data communication. My excitement only grew. I met Steve in real life at Hamvention in May 2022, and we sat and chatted for some time. Among many other topics, I asserted that his newsletter was valuable and that Hams would pay for it. I later put my money where my mouth was and became founding subscriber 0. Because in the digital data world, we start counting at 0. I am inordinately proud of having been out in front on this. Steve and Martin Alcock, VE6VH, have brought IP400 into the world, and it looks to become a fabulous tool for data communication. Without further ado, please welcome Steve Stroh, N8GNJ, editor and founder of Zero Retries.
Thank you, Steve, and thank you, Bill. Give me a moment, folks, to get queued up here. And you should see the opening slide. Please confirm. Bill, Steve, confirm that you're seeing the opening slide.
Yes.
Okay. Okay, welcome. This presentation is, excuse me just a moment. I got to fix one thing. Okay. This presentation is called IP400 and the Digital Future of Amateur Radio. And I'm honored to be, I didn't know I was your inaugural webinar speaker. They left out that detail, but we'll make it work. It's going to be a little bit of a, it'll start slow, but it'll pick up and the dots will get connected along the way. Because I have to tell the story about Zero Retries first, then the digital future that I started encountering, and then IP400, which is helping to be the digital future that I want to create. So here's a little bit about me. I got interested in enough in amateur radio. I'd known about amateur radio for a long time, but back in my early teens, I found a stack of 73 magazines at the local library, but it wasn't quite enough to push me over the edge to get licensed until it got interesting for me in the 1980s with packet radio. And one of the formative events in my amateur radio career was moving to the Seattle area and then I fell in with this group called what eventually became called the Puget Sound Amateur Radio TCP/IP group. And we had multiple data repeaters that were bit regen 9600 bits per second, and we were running TCP/IP over them with an internet gateway. That knowledge of TCP/IP in those early days for civilians was enough to help me talk my way into becoming a sysadmin job, which was a lot better job than the electronic technician that I was at the time. And then eventually I parlayed that almost accidentally into a writing gig for Boardwatch Magazine talking about wireless ISPs, or ISPs ought to be using wireless technology, the Part 15 stuff that had just kind of come into the world. Why another newsletter? Well, as I say kind of at the bottom, I wanted to write Zero Retries as a love letter to amateur radio about what I thought was the relevant things that are happening um, in amateur radio and help portray amateur radio as relevant in this era. Because face it, uh, doing contesting and DXing does not exactly get the wheels spinning for a software developer trying to learn more about radio technology. So what's with the name Zero Retries? I get asked this every single time. Basically, in packet radio, you send out a packet with a checksum. At the receiving end, you decode the checksum and you compare it against the data you received. And if the checksum matches the data, then it's considered good. You don't have to do a retry. So Zero Retries is a good transmission. And I credit Bud Churchward, WB7FHC, for creating the name for the now defunct packet radio organization here in the Seattle area called NAPRA, Northwest Amateur Packet Radio Association. A few things about Zero Retries that I learned along the way. I wanted to go get the stories. I was never going to be content to just wait and republish the stuff that comes in the door. I apologize about the busy background. I did not know that that was live. I'll have to make a static background from now on. In the 21st century, and you're trying to attract the internet generation, it does not work to put up a paywall. Your information behind a paywall might as well be invisible to this generation. It just does not work for, at least it does not work for hobby activities like this. You're getting interested in amateur radio. You want to go out and learn things. You start learning from what you can find, and you can't find anything that's behind a paywall. So Zero Retries is free, and QST's competition is not necessarily me, but it is Surrey Amateur Radio Communications, the communicator newsletter, which clocks in at reliably at over 100 pages. It's published bi-monthly. It's published free as a PDF, and you can even read it online as a magazine now, just page by page. It's very cool. And I am not the least bit concerned that some people come into Zero Retries and sign up and then unsubscribe. There is churn, and that's fine. What I publish is not for everybody. This is the only slide that I'm going to read, and I have to, gonna be a little tough because I have I'm gonna have to do this. Many years ago, this is by a guy named Don Lancaster, who wrote, among many other things, the TTL cookbook, which is what I learned digital electronics from. Many years ago, I was at a rock concert. The opening act was a single flute player standing solo in front of the closed stage curtains. His job was to warm up the audience for the high-priced talent that was to follow. He was good. But as he went along, the musical vibes got stranger and stranger and then totally bizarre. He was playing chords on his flute, combined with utterly unbelievable riffs. Much of the audience got impatient and bored at what seemed like a bunch of god-awful squawks. Then I happened to notice a friend beside me who had both been in and taught concert band. He was literally on the edge of his seat. He turned to me slowly and said, "You can't do that with a flute." Of the thousands and thousands of people in the theater audience, at most only 5 recognized that they were witnessing a once-in-a-lifetime performance of the absolute mastery of a difficult and demanding instrument. Lancaster's advice: always play for those 5. So that really resonated with me when I knew this advice from before I started Zero Retries, and it's resonated with me ever since. And I write Zero Retries for people like Steve, who, like me, want to learn about this technology stuff, not just data, but microwave, space, all kinds of technology in amateur radio, and that you can't get anywhere else. So if all the stuff that I was reading and enjoying in the 1980s still existed, I would not be writing Zero Retries. So this is something that I discovered along the way. I did not know this before starting zero retries. There is a new type of amateur radio operator coming in, generally more technical. Examples are engineering students, software developers, hackers, makers, open source advocates, etc. They want to be doing um, data communications over radio. And you don't need any better evidence of that than watch the fantastic rise of the use of Meshtastic on LoRa. They are building networks. They are developing new hardware. They're developing new software. All open. Every bit of this is open source. It's operating on the 902 to 928 unlicensed band, so they, anything goes there. So they're having a great time, and it's worldwide. It's not just the U.S. Very active in Europe. I don't know about Asia, but I assume so. So one other thing about this generation, or this, not generation, but this class of amateur radio operator that's coming in, is that they treat the internet as just another utility. Why wouldn't you use the internet with your radio activity? And they text a lot more than they talk. And here's an example of how different this is. They're getting licensed at conferences like DEF CON and GNU Radio Conference. That's their level of expertise coming into amateur radio. So, and I try to speak to this audience in zero retries. Uh, mission creep of zero retries. There's going to be several slides like this. There were things that I just was not aware of until I started coming in on amateur radio, or it's coming in to write zero retries. There was most of what I do in zero retries is I expose what's already going on, but they're keeping these activities are staying within their unique silos. One particular modem has their own mailing list, and they don't go afield other than that mailing list to try and expose it. They don't write articles for QST or anything else. They just do their thing. Some of the things that I talk about here is Arden. I'm an advocate of a geosynchronous Earth orbit payload for the Western Hemisphere, like QO100. I wish we had one. And I've talked a lot about why we don't and why we should and how we could. It's kind of a lonely quest, actually, because AMSAT sure isn't talking about it. I talk about a data mode called VARA FM, 25 kilobits per second on a standard VHF UHF channel. Amazing technology. GNU radio, software-defined radio, and if you use the GNU Radio Companion, you can make yourself a radio by connecting the blocks. No exaggeration. And zero retries allows me a platform to say what I think. I don't say everything I think, but I say I try to say the important things when I think it's important to say them. Example of mission creep was that I started diving in out of my own curiosity into something called the M17 project, which is a digital voice for VHF, UHF, FM. It's implemented entirely as open source. It was initially a specification. Then it started getting embedded into hardware and software. So you can now do digital voice without any proprietary technology at all. And what happened to me, so I started finding all these bits and pieces. I hope I'm not being pejorative when I say that M17 project several years ago was a science project. It was cool. It was interesting. They were doing great things, but they were having fun, but they weren't really progressing towards a goal. So again, I started studying it and I started explaining it in zero retries. And I concluded in an article that M17 had all the pieces that were necessary for it to, kind of go mainstream. There was repeater capability. There were radios that could be modified. There was the modem that could modify other radios. And there was a back end through I can't remember the name of the back end. Brandmeister. So I talked about this as, hey, M17 is ready to go. We could be using it now, the same way we use DMR or D-Star. I started a mailing list for the users of them instead of just the developers. The developers had their own channels, but the users didn't, and you kind of got shouted down almost when you asked, silly beginner questions on the developer list. That led to Connect Systems creating the first radios that had M17 built in out of the box. There is now the M17 Foundation, a dedicated group that was created in Poland. First M17 conference will be held in Poland, unfortunately in September, same time as my conference, but so be it. And this was a total surprise to me. There were people that came out of the woodwork when they started understanding that M17 wasn't just another digital voice mode. It was an open source digital voice mode. And all of a sudden they got excited about that because open source, hey, count me in. I want to get involved in this. I want to start exploring it. I've done other deep dives like M17 for a mode called MMDVM TNC. I'll be talking about that in a bit. I did one of my first deep dives was VARA, really at trying to understand how VARA FM worked. I couldn't understand how it could work, doing what it did, but it does. I've concluded that groups that are going to succeed have a group behind them. They're not just solo efforts or random projects posted on GitHub. They have to you got to put some wood behind the arrow. And some examples of that are Arden, the APRS Foundation, now that Bob Berninga, WB4APR, is not with us anymore. Like Tapper did for Packet Radio. There's an organization behind FreeDV, and there's an organization behind WinLink called the Amateur Radio Safety Foundation. I think that amateur radio, and again, this is mission creep of zero retries. I didn't start with these ideas in mind. Amateur radio, I think, needs a new focus for the 21st century if it's going to survive as we know it and love it. I think amateur radio is losing relevance for emergency communications. I am absolutely not saying, as I've been accused of, I am not saying that amateur radio isn't useless, that is useless, that I am not saying that amateur radio isn't needed. It's fantastic for personal communications. It's, for tactical communications in certain situations, but the way that we structured it back in the day, we've traditionally structured it as, served agencies, and we train with the served agencies. These served agencies are going to start sending out their IT folks with a Starlink Mini in a backpack, to plop it into a temporary headquarters, in a disaster. Iridium put up an entirely new satellite constellation, which is it's not even comparable to what their old one used to be, analog cellular in orbit. This one is just fantastically capable. It hosts many different payloads. So you can have a worldwide push-to-talk walkie-talkie network as, anywhere in the world, as long as you can see the sky. FirstNet is a service of AT&T now, managed by National Telecommunications and Infrastructure Administration. They are managing it and keeping AT&T honest about reliability statistics, capabilities, etc. Mobile phone to satellite, we have that now experimentally. It's going to become mainstream. It already is mainstream for Apple users of the last two iPhones generations. You wander outside cellular coverage. If you can see the sky, you can not call, you can text, and it's constrained a bit, but it's getting better and better by the month. So my new mission, what I think is in contention for a new mission for amateur radio, is that we really need more radio technology expertise. And software-defined radio is the wave of the present. And we don't have nearly enough technology like this. And I'll make that point in a minute. we need to be promoting amateur radio to all of those folks who are going to get involved in software-defined radio. Again, university students, hackers, makers, IT folks, software developers, and make amateur radio seem relevant to them. So they choose amateur radio instead of trying to figure out how to do what they want to do in unlicensed spectrum at very low power, up high in the microwave region, for 2.4 gigahertz, for example. And instead of trying to learn how to use HF or VHF, UHF. And I really believe this now, and I can't go into all of the specifics about why I feel about this. Some of it was privately shared with me, but I really believe that if amateur radio doesn't adapt to this trend, it could become the unlicensed citizens experimental radio service. And here's the reason is that, this is not a joke anymore. China is starting to make their own unilateral standards. And is it going to work for us if we become captive, passive customers of Chi-Fi? I don't think so. They're going for it, and they don't have to play Mr. Nice Guy because the U.S. isn't playing nice with them. Again, morphing zero retries original mission. I'm advocating for regulatory reform in now 3 requests for comments by the FCC in 2 years. And here's just a list of a few of them. And one of the and I responded pretty thoroughly in this last one about what can we delete, and I kept my comments to things they could just simply delete. I wasn't really advocating for new capabilities, but just deleting a bunch of arcane regulations. If you really read through Part 97, thinking of how are you going to adhere to all of this, it's crazy. They just ought to wipe out all of those arcane classifications of data, modes, etc. So, okay, so here we start to transition from what I've learned and done in zero retries and what we're going to do with IP400. There are 5 decent systems besides packet radio. Arden, ICOM DD mode, 128 kilobits per second. Hardly anybody knows that this exists. New packet radio is a cool one. And I was really hyped up on new packet radio until I discovered that if you want to run the maximum 1 megabit per second, you need a 1 megahertz channel, which on 420 to 450 it runs afoul of the rules as they are written at the moment. Again, VAR FM talks 25 kilobits per second on a standard UHF VHF channel. It's amazing that you can make that work, but the author did a fantastic job of layering multiple different techniques for a robust and fast mode. And 802.11 Halo is a really interesting mode that hasn't gotten a lot of traction yet, but there's more and more silicon coming along to make these radios available. And I showed a picture of one in the last issue of Zero Retries. It's basically a little bullet case that you could put up high. So again, segueing to talking about IP400, I did this thought experiment in Zero Retries, which I do periodically. Some work, some don't. This one worked. I was imagining a confluence of trends that argued for that we should be doing a better type of repeater. We should be adapting these repeaters. So the new type of amateur radio operator that is coming in that I already discussed. Another trend is maybe most repeaters have gone quiet. I haven't done a study of this, but my observations are that you just listen to repeaters all day long, scanning through them, and most of them are just dead quiet. There is an increase in data modes because we're wanting to do better data communications for MCOM. And one of the things that has revived it is the use of VARA FM on VHF and UHF. It just works so much better than packet radio, and you can now send spreadsheets instead of having to compact them down into comma delimited files and then repack them. You can just send the Excel file if you want, because it's fast enough for that. But you're still doing simplex links into hub stations like WinLink radio message servers. So we have all these repeaters, but they're not doing anything, and they could be doing data, but that's data and my repeater does voice. So it is feasible to add data capabilities to repeaters. There just isn't a good blueprint on how to do this yet. And for the argument that well, we don't do we we don't need to do data over repeaters because you've got digipeaters, and digipeaters were, quite frankly, a hack back in the early packet radio days to kind of extend the range of these heathen packet radio systems. It was a hack then. It's a hack now. The real solution, as we learned back in Seattle in those 1987 through the early 90s, data over repeaters works fantastically. For one thing, you're not jamming each other. You can hear in real time when somebody else is using the repeater, so you don't try to transmit, unlike with a digipeater. I could spend an entire seminar on that particular subject. Okay, so again, super repeaters as a thought experiment. Crossband makes a lot of sense. So imagine a repeater that has multiple inputs on multiple bands. So use what you have. If you only have a simple radio with a 1200 baud packet radio TNC, there's an input for that. If you have a 9600 baud radio like a Kenwood TMD 710 that can do 440, there's an input for that, etc. And then the repeater turns around and spits out a high-speed data stream. Now, I didn't invent this concept. I ripped this off blatantly from a concept called a PACSat, packet radio satellite, which had 4 channels going up and one high-speed channel going down. So for the users, this makes it really easy to get involved in data communications on a satellite, on a repeater. And it's as you develop your capabilities, you switch inputs and you can do faster data. But you got to have a radio to receive this special super gee-whizzy data, high-speed data stream, right? Well, you probably already have one. It's called a RTL SDR dongle. That's a perfectly valid way. And say the output of the repeater is on 220. No sweat. This thing receives that. It can receive a nice wide channel. It can decode it. You hook it up to a Raspberry Pi, dedicated $35 computer, add some software to it, and boom, you are listening to the high-speed data stream of that repeater, which, by the way, can also include interleave digital voice. The multimode digital voice modem, it's not just hardware, it's a software spec, so it can be incorporated in something like the super repeater. And the author of the MMDVM created a very well thought out high-speed data mode he's calling MMDVM TNC. 9600 bits per second, has interleaved forward error correction, uses a much more robust transmit waveform than standard audio frequency shift keying or even frequency shift keying. So now we start getting into the meat of the thing. My super repeater ideas were entirely blue sky. Again, it was a thought experiment. This is what seemed to me the way we could be doing things. And it got the attention of somebody who actually was doing such things, Martin Alcock, VE6VH. Martin was working with radio radio chipsets to do higher speed operation in the 420 to 450 megahertz band. His original ideas were to refit repeaters to be able to do data more repeater to repeater and start replacing internet over cellular links. But he was watching these chipsets and I was not. And he started explaining to me how capable these cheap chipsets were, because they were designed for the Internet of Things market, Internet of Radio Things. Um, and so more than adequate for us. And because in Europe there's a 433 megahertz unlicensed band, so these chipsets would do 400 megahertz. Well, actually, way beyond what 433, and including wider than the 420 to 450 megahertz band in the US. So I pointed out that the biggest lack in my super Peter idea that I didn't have any idea how to solve, so I didn't even try, was the lack of a real decent data radio. We're using things like, still using things like TM D710s and TM V71As and other radios that have a 9600 input, or I call it flat audio. It's basically a way to bypass the preemphasis and de-emphasis stages for a modem. That was as good as we're able to do right now. Well, that and new packet radio. So Martin explained to me that the data chipset that he was looking at could easily do what I thought was needed. And wow, we bonded over that and a few other things that I'll talk about. And then he created the IP400 network project. And IP400 stands for Intelligent Protocol on 400 megahertz. And we started this in January 2025, and the progress has been amazing. Let's see. So a few other inspirations that we have rolled in that have influenced our vision for IP400, as we're both fans of Arden, Amateur Radio Emergency Digital Network, which is a firmware replacement for certain microwave networking systems. And it works great. Fast data, just TCP/IP and Ethernet, if you can do microwave. And again, an influence was these new capable chipsets. Now, and I need to make a distinction here. The chips that we're looking at are designed for data, only data. They are not I can't remember the name of the chipsets that are very commonly in use, especially for MMDVM, STM33, something like that. Anyway, those are designed for walkie-talkies, cheap, one chip you can build an entire walkie-talkie around one chipset. That's not this. These are for data. And Martin's work was already sponsored by the Alberta Digital Radio Communications Society. And that's a fantastic leg up, because we don't have to create an organization to sponsor the work, to have, tax exempt contributions, etc. We have a channel to evangelize IP400, in zero retries. And my messaging going forward is that IP400 is the packet radio revolution of the 21st century. We already have a minimum viable product that is, I'm allowed to say, is in pre-production. And you will see it in summer 2025. And it will be a major focus of what we are showing off. And we still have 3 months or so, 4 months before the Zero Retries Digital Conference in September, which I will talk about in a minute. So here's some of the IP400 technical details. We are aiming for 100 kilobits per second or faster. I'll talk a little bit more about this. And it's a black box radio, Ethernet in, radio out. And we're trying to make it as simple as the same way you would set up an Ethernet switch in your office. You'd plug everything in together with Ethernet cables into a Ethernet switch, and they just, the data just starts flowing to where it's supposed to go. The switch figures it out. We want IP400 to have a transparent, lightweight protocol that will, if you want to send something on AX25 to, from station A to station B, you wrap up your AX25 transmission into the protocol. It transports across the network. It unpacks at the other end. And I emphasize again, this is not radio plus modem. This is a radio that's inherently data. It doesn't have an analog stage. We want to do mesh networking for the people that do getting the repeaters converted to be able to pass IP400 is going to be a slow process, and we don't want that to be wait for that. So we want IP400 to have mesh networking out of the box. It might be a little rude, crude, and unattractive initially, but that is very much a strong design goal to get mesh networking into here and have it work the same way as Arden. But we are very much working towards having a offering of a repeater module that will allow IP400 and all the other legacy modes, FM, the digital voice modes, and M17. So our long-term plan is to integrate OFDM. This is the secret sauce and what is really going to put amateur radio in VHF and UHF ahead of almost every other system that we know of. And the key to OFDM, just like in real estate, is location, location, location. The secret sauce to OFDM is subcarriers, subcarriers, and subcarriers. You basically chop your channel into a whole bunch of individual RF carriers called subcarriers. You stripe your data across subcarriers. You manage each subcarrier by itself, and you add forward correction, not only on your data, but on each subcarrier. Martin and I found a lot of common ground because I knew of his former employer in Canada, and I had actually visited that employer in my earlier writing career, and they were showing off their new OFDM system they had a directional antenna in a box truck. They pointed the antenna at first of all, they oriented the box truck so that the open end was pointing towards their tower. Then they took the antenna and oriented it so it was pointing at the back of this is about a nightmare scenario for a typical, because you're making multipath, but OFDM, because basically uses multipath. So the thing worked fantastically, and it was a fantastic demonstration. And I was saying, wow, it's so cool that we can do that this new technology allows something like OFDM. And the president of the company chuckled and he says, well, actually it's like 20 years old. This was 20 years ago. So and so OFDM is like 40 years old now. The trouble is that 40 years ago, to do OFDM, if you wanted to have an OFDM radio, you had to ship a VAX mini computer with it to do all of the data management. So now we've got FPGAs. These next slides I've borrowed from Martin. Project Martin has a very intense slide deck. These were some of the selected slides that he does a better job explaining than I could. This is kind of some of his goals. Mentions a few other things that I didn't. For example, we expect to be able to use max bandwidth of 2.5 megahertz, and I'll touch on that touchy little subject in just a minute. This is the beauty. This is the money shot. This is a early version of the IP400 radio that we will ship in summer 2025. Now, the silver shield underneath, or that's right next to the antenna connector, that's the radio. Everything else is kind of just support circuitry for the radio. Kind of on the left end of the board is a power connector for 12 volts in. There's a power regulator there. There's some I/O circuitry. There's some indicators, some headers, some various bits and bobs, resistors, capacitors, etc. But the radio is that silver block right next to the antenna connector. So this is a pretty low risk minimum viable product that will let us do all of the things that we imagine for IP400 in its initial stages. And everything is going great. I'm allowed to say that the IP400 radio is in pre-production. I can't go into any more details than that. A few more details about the actual protocol, the on-air protocol. I don't want to get bogged down in this because I can geek out on this, but all of this stuff is working to a great extent. And so here's the other money shot to me. So IP400 is going to constantly be transmitting that center portion. This is, and I've heard this, I refer to this as the hailing channel. This is going to be transmitting a lot of data, small bits of data, all aggregated basically all the time. Now, when you go to do something like video, the OFDM carriers start spreading out from that channel. So again, 2.56 megahertz wide channel as needed. These carriers shrink and grow as you need. So the theory, you can get lost in the theory, but the reality is this thing is just this. I really, really believe, because this is all staying in the digital domain on RF. This thing is just you're gonna plug and play, and this thing is gonna work, and it's gonna form up networks. It's just, I really think this is gonna be packet radio of the 21st century. We're getting towards the end here. I'm gonna put in a plug for Digital Library of Amateur Radio and Communications, and I'll explain why in a second. This was funded by the Internet Archive, or sorry, this is funded by Amateur Radio Digital Communications to the Internet Archive. We are just one, DLARC is just one project of thousands in the Internet Archive, but it has become a worldwide library of amateur radio. There is stuff from every country now that has an amateur radio population. It was really amazing to see some stuff from Russia get added, or USSR at the time. And an awful lot of it has never been online before. It's never been accessible to the masses. So here's the reason I really love it. It's a fantastic resource. I have taken in what I've come to want to do in IP400, I've taken inspiration from a system called TextNet, which I finally found some articles describing the internals of TextNet. I learned about PackSat from some really seminal articles. I contributed Packet Radio Magazine. I was the only one I've ever heard of that had a collection of Packet Radio Magazine. I found microwave conference proceedings at Hamfest. I also contributed AMSAT's Orbit magazine, which was a fantastic magazine back in the 80s or so. It was a wonderful treatment of amateur radio in space. And man, if we could be doing that again, but no, it's all tucked behind a paywall. So AirDC just approved a new grant for DLARC for 2 more years of fantastic work. I couldn't be happier. AirDC. AirDC is angel funding for amateur radio, especially amateur radio development. They just came out with a new focus. One of the things that they want to be doing is space. They want to be funding projects in space now. The way they became angel funding is that they sold a block of 16 million IPv4 addresses, which was basically a license to make money. This is all public information now, but they sold the addresses for more than $100 million. They immediately invested that. It's generating I can't remember the term, a nice return, which is going out as grants and internal operations, among other things, to pay a staff, which is doing a great job. And It is also creating a much more capable 44 net for the remaining 12 million IPv4 addresses, which are reserved for amateur radio and other experimental use. The reason I bring it up here is that ARDC does a request for volunteers at the end of every year for the coming year, and for two committees, the Grants Advisory Committee and the Technical Advisory Committee. Both of those are fantastic opportunities. You will see and learn amazing things that you'd never heard of before. They always need help. They always look for help at the end of the year. And I strongly advise people who have technical capabilities to or just want to help out and see good grants get funded. It's a lot of legwork. It's a significant block of time. So watch for the call for volunteers towards the end of the year from ARDC. Zero Retries Digital Conference. Tina and I, my wife Tina and I, really loved what Tapper and ARRL had done with the digital communications conferences. And Tina sponsored the two most successful DCCs here in the Seattle area. The first one was in 1996, and I don't remember when the other one was. It is basically amateur radio's R&D conference. There are other conferences that are more narrowly focused, such as QRP and microwave and space, but the DCC was really the omnibus of technology and amateur radio. Unfortunately, they aren't being held anymore, at least in person. The last one was 2022. There was a very abbreviated one in 2023 that was entirely online. So having a national conference, an international, it's also been held in Canada, is really important. And so Tina and I had decided that we were going to do a digital conference in conjunction with Zero Retries. And then we got the push to do it this year when we learned that the GNU Radio Conference this year was going to be held in Everett, Washington. So that conference runs on Monday through Friday. Saturday, the conference center was not spoken for, so we took a big gulp and put down a big deposit, and we're going to tag on to the GRCon. We're not formally affiliated with GRCon, but we're certainly going to try to create some synergies between the two conferences. And the Zero Retries Digital Conference will be very carefully cultivated to, focus on the really interesting projects. You're not going to just sit there and be fed filler. Here's some further reading for those who are going to look at the slides afterwards. And here's my contact information. Zero Retries newsletter, free as in beer. There are paid subscriptions, and Substack will show that to you first because that's how they make their money. But you can pick the free option and you will get 100% of the same content as the paid folks. So the paid folks are really, really appreciated because they don't get much love. But they help support us. And, for example, they were a big help when we decided to go to New Jersey for the HAMSI 2025 conference. It usually publishes on Friday, usually at 15:30 Pacific. Sometimes I get behind, sometimes I goof. But you can look for it reliably every week. And there is my email address for those who want to contact me directly. And with that, it's question time. And I will stop sharing at this point. You don't need to keep seeing that.
There we go.
Well, thank you, Steve. That was absolutely fascinating. And Martin, VE6VH is on the webinar. We can promote him to panelist and show him if he is willing, and you would like to have him up.
Oh, yes. Please.
All right, let me go find Martin. And we do have some questions in the chat that we can go over as well. So let me
So, first off, I want to, going from top to bottom, there was Jim, WA4YWM in Quakertown, said that he was glad to see your emphasis on GNU radio, that he's done some work, and but he hasn't found anyone around southeastern Pennsylvania working with it. So I went looking for how to contact him, and he does not have an email in his QRZ listing. But there's at least one fella here who'd be interested in playing new radio with him, since I'm interested in playing any kind of radio, especially digital radio. Did you see another other than Martin? You got Martin up there, great.
Yeah, Martin's up on the screen, so let Martin welcome him in.
Hello, Martin.
Thank you. Nice to meet you all. Welcome to my playroom.
See, Martin walks the talk. You know, I talk the talk. Martin walks the talk. He's got the chops.
Well, we'll just do a little bit of a sneak preview here. IP400 nodes by the dozen. You saw it here.
See, this is why I have so much confidence in talking it up. Martin is just grinding away. There's so much I would love to talk about that no, not yet.
Martin, you have the floor.
Thank you. Well, thanks very much, Steve. That was a great presentation. I really enjoyed that. And I like the way you framed it with amongst all of the other things going on as well. I'd like to back up a little bit to how this whole thing started. I've been building repeater controllers for a while, and then anybody reads CQ Amateur Radio in 2016, I published an article about an FPGA-based controller. And then I started looking at the second generation of it. And what struck me was there was no single controller out there that could handle analog and MMDBM and M17 and all these other modes together on a single platform. So I started to build that. And one of the things I'd built into it was the 400 meg link, so quote unquote, and using the partisan ST Micro STM32WL33, which has been under NDA until last November, finally came out of the box, and is now commercially available in terms of evaluation platforms and chips as well. And this thing struck me as being really interesting because it had a built-in 400 megahertz radio. It would do 802.15.4, which is the used by powerline utilities. They're claiming a distance capable of 3.5 kilometers. That's 3,500 meters, or approximately 2 miles, barefoot with an antenna. Power output of 100 milliwatts. And everything integrated into a single platform, including an ARM Cortex processor, which has kind of become the industry norm now for embedded processors. So I started looking at building one of those in, and then Steve and I reconnected after many years later. The company, by the way, I work for is called WLAN, and we were the founders of the WiMAX Forum. We're also the inventors of 802.11a, which is the first OFDM standard, which now has become 802.11g. So we were involved in that, and we started talking and said, what would be really interesting is if we wrap this whole thing around a mesh network. I had the ability to create a node that could mesh with other nodes, and any node on the mesh be a repeater controller as well, that now could have redundant connections to get from point A to point B. And this really sparked my interest. And we went to town, and the net result is we've actually have some software available. If you go to the Alberta Digital Radio Communication Society website, that's adrcs.org. You'll see a little thing about IP400, but it points you to the GitHub site, and points you to a chat room as well on groups.io, and you're welcome to join that and keep up to date with the project. We're about to go through a big announcement in a couple of weeks, and I don't want to take anybody's kudos away by pre-announcing stuff, but let's say if you're going to Dayton this year, you'll find it interesting. And so far, so good. I mean, we actually have working nodes now at 100 kilobits a second. And I'm sitting here coding a reflector at the moment that will be up on the web fairly shortly. And onwards and upwards. The next big push forward that Steve alluded to was the OFDM, the dual FSK and OFDM mode. What we've basically done is gone back to OFDM and punched a hole in the middle of it and said, okay, here's where we're going to maintain this lowest common denominator carrier, which is within what you folks can do now. Hopefully, we'll be able to do in the future. And but we'll grow the bandwidth as we need it in order to fulfill the traffic requirements. And that is the next phase that we're also applying to ARDC for a grant to carry that out. And that'll be exciting, but that's a little ways off yet. Anyway, that's all I really got to add at this point. As Steve said, many questions.
Yeah, I actually have a couple of interesting ones here that I'm
Fire
glad you
away.
joined. Yeah. So there seems to be there's some interesting questions. I'm going to try and kind of combine a couple
Okay.
around how the RF is generated for the IP400. Is the Pi generating the RF? Is it a hat for the Pi? Folks
It's
want
a
to
hat
kind
for the
of
Pi.
understand. It's a hat for the Pi.
Yeah, it's a hat for the Pi.
And all
So I
of
have
the all
I
of
have
the
a blank
RF is
board.
being done on that chip that I pointed out, and well,
There's
better
there's a
demonstrate.
blank board.
Okay.
So it's in the Pi Zero hat form factor, and because that seems to be a popular form factor for hotspots, so we're following the trend previously set by hotspots.
But by putting all of the work, all of the software onto a Pi, that frees us from any software development of an embedded processor on a board. All that complication. We can just push. We can make maximum leverage of all of the networking, all of the protocol work, you know, user interface, modes, BBSs, terminal sessions, et cetera. All that stuff is, that's all open source available. We run that on the Pi. We don't want to get into the business of, we want to use commodity capabilities whenever possible. And the Pi is the highest use of commodity computing we can get. So, and it doesn't have to be a Pi Zero. This first version is capable of running on a Pi Zero, but it doesn't have to be a Pi Zero. We can use the Pi 5 if you want, I suppose. Oh, I'm sorry. I'm speaking out of turn because that's Martin's department, and there are some incompatibilities in the Pi 5. So, but it doesn't have
It's
to be a
just a
Pi
power
Zero.
issue.
Yeah. So.
I just brought my desktop in. I don't have any video on my desktop. That's why I'm on a tablet. But if you could allow me to present with my desktop, I'll give you a little demo here. It's probably got a picture of a Caribbean crab on it.
while you're doing that, there's a lot of folks who are really wanting to kind of come in and help with the project. Is some folks are saying they're interested in helping with the coding part of it. And a lot of enthusiasm in the chat room regarding the software-defined radio aspects, GNU radio.
The presentation was going long, and I basically distilled 3 months worth of writing that I've done in zero retries into this presentation. But one of the many things that we want to do is we want to come out, and Martin has done an admirable job of a spec. I've seen the specs, including the stuff that he hasn't yet published publicly. And what I think is going to happen is that some bright young grad student or somebody is going to come along and want to create IP400 entirely in a software-defined radio, GNU radio block, for example, or a series of GNU radio blocks. So you're going to be able to go and pick your favorite software-defined radio, load GNU radio onto it, load IP400 blocks into GNU radio, and be completely compatible with everything we're doing. There's no secret sauce in this. Now, it's not going to be as efficient because you're doing it in software instead of hardware inside these 802.15 radio modules, but it'll be doable. And there's plenty of OFDM. There's plenty of all the other modes. And once we get to that point where either the IP400 radios or IP400 running on a GNU radio, you can also do all the other stuff. So that's way down the development cycle, but it's all in there.
Okay.
So one of the comments that came up, and I'm going to turn it into a question, is from a fella, Sam K. I'm sure that K is the beginning of his call sign, but I don't have that on my screen. I'll get it for you. But his comment is, this sounds like somebody took OFDM DOCSIS and adapted it for ham bands. I wonder if you rig a CMTS to do IP400.
No.
What a CMTS is.
Cable modem termination system.
Yeah.
Yeah, no. Chalk and cheese.
The CMTSs are incredibly powerful. They're also incredibly complicated. And yes, that's not to say that it's not doable, but so for example, there have been several software-defined radios, and I cannot remember the Radio Berry was the one I think of, that was using a CMTS chipset. But that's a lot of work. And our modulations are simpler than that for now, and we can get by with the cheaper, simpler chipset that Martin has chosen. Chipsets, actually, there's a family of them. So I am very much an advocate of the minimum viable product, and I would not have gone forward with this unless I was convinced that we had a minimum viable product that we could ship in a reasonable amount of time. Because God knows, I documented about 4 of them, projects that talked a good game but never went anywhere, never actually got hardware into the hands of individual users, and that's very much our goal. We want this out in the world. There was another point I wanted to make. I still can't remember the name of the acronym, but Martin and I had this spirited discussion a couple of weeks ago that I documented in zero retries. Martin was showing me this, and I was just in awe because the ideas for this go back 20 years, back to the Seattle group that I was part of. And Martin was, zipping along, and I said something about, well, I sure hope we can use this in the US. Eventually we'll get the US, the silly dial back the performance mode of the US. And Martin kind of bristled and said, I won't be doing that because very appropriately, Martin in Canada and the rest of the world does not have the silly regulations for the 400 megahertz band that we have in the US. Our limitation is 56 kilosymbols per second and a maximum channel size for data modes of 100 kilohertz. Nobody else does that. Nobody else. So IP400 is going to just rip, every place but the US. So I said, okay, point taken. And then I put out a call for interest on the IP400 mailing list. And I started getting drowned by all the responses of people that want to join my project to either request a special temporary authority or a Part 5 experimental license to be able to use IP400 at full speed in the US. Yeah, I think so too. I think at a minimum, we're going to be able to demonstrate no harm done. This is innovation in amateur radio, and nobody else is doing anything like this. And this is why we need these changes. So,
Great. Is it possible for me to share my desktop screen?
Yes, you should be able to. You should be able to just share as a panelist.
it's a different
No,
computer.
different computer. It's my desktop, not my tablet.
No, you'd have to log in.
I've raised my hand,
Let me
so
see
you
if I
might be able
can.
to see it in the gallery.
Let me see if I can. I'll have to make that computer a much.
Yeah.
I see it. See if we can do that. It's gonna.
Here we go.
It's
Here
gonna
we go.
confuse you. Let's see if it works. We're learning about this too today.
Cool.
Oh, okay. That's kind of an interesting approach.
Excellent. Excellent. Yeah, this machine has no audio or video on it. So I'm going to show you a couple of interesting little things here. First of all, I've got two putty sessions going here as serial communications only, and I'm talking to a couple of Nucleo boards. But Nucleo is a brand name that ST Microelectronics uses for their evaluation modules. And I'll show you the real thing is over here. There it is right there. Now this is the board here. Now under that can at the top there is the 400 megahertz radio. And the board below it actually is a debugger. It allows me to download and set breakpoints and debug the firmware. And you'll notice it's connected to a Raspberry Pi as well. And the Pi by a serial peripheral interface. And the two of these are actually talking back and forth over the SPI. So I'll show you a couple of things here. First of all, I can connect to the, I've got the wrong camera. There we go, there we go. What you can see on your desktop is my desktop. And on the left and the right-hand side here, I have brought a menu on each of those two. I've got another module, just another one, just like the one I showed you. So first of all, it's a very simple menu. You can see what we've got. I can tells me what my radio ID is, what my call sign is, and I can change any one of these, what RF frequency I'm on. Currently, I'm running at 4 FSK at 100 kilobits per second with a peak deviation of 25 kilohertz and an output power of 9 dBm, and my maximum power is 20 dBm and an RX squelch of -60. Any of those parameters can be changed by simply going into a menu item here, set the radio parameters, set the station parameters, set the clock and everything else. So let's see, it's got a small mesh status. So it should be seeing the other one I've got here, which is there. And if I go to this one and do its mesh status, as you can see, it sees two others. And you'll notice that so it's built the mesh table. You can see this one and this one together. And in the mesh table was the received signal strength in dBm of when it received what we call the beacon frame. And the last time it heard it, the number of hops, so that's with a direct communication. And the capabilities of the remote station are, it's running FSK 100, it can repeat frames, and it's putting out an output power of 9 dBm. whereas this other station can only can see putting out 14 dBm, and you can also see it as an IP address which has been calculated from a unique ID register inside the part, and also some stuff stolen from the call sign. So we can come up with a unique ID. From the unique ID, we can come up with an IP address without having to worry about an ARP protocol. So all that stuff is baked in to begin with. And I can just go back to here, go back to here. Now, if I put it as a very simple chat application, if I put the chat application running here, chat application running there, and type hello there, I'll hold my breath, it comes out on the other one. And if I go back over here and say hello back, here it is. And so this has told me that it's received from the call sign, from the IP address to a broadcast address. That was the content of the message. So that's the basics. We can now send and receive frames. As you can see, the speed's fairly zippy at 100K. And just hit Control Z to get out of there, Control Z to get out of there, out of there, out of there. Here we go. The other thing that Steve showed you, which I will show you again, is here's the hat board. This is the pre-production hat board that he alluded to. And over here we have a 12-volt power supply as a 5-volt regulator, a 3.3-volt regulator. This is a reset switch. This is connections for the debugger. And this is a module that we've produced. And the module is a complete self-contained IP400 transceiver. So you can include one of these into your own project just by simply laying down the correct footprint and wiring it up as you see. Here we have the antenna connector. And here we have a FET connected to a 2-pin connector, which can control an external power amplifier. And we are working on how to increase the power output to 25 watts, 35 watts, which we feel should be plenty. Yeah. The candidate for the moment is a Mitsubishi monolithic MMIC monolithic module, and which we're in our 900 meg radios, but we can get them for 400 as well. And this is the typical Pi form factor. And there's the 3D component view of it. All the LEDs down here indicate the power is on. The mode one is bidirectional, which is green for receive and red for if something went wrong. And this one here is the transmitter. And there's a little reset button.
Nice.
There we go. Okay, thank you.
Yeah. There was another question about how the IP400 network might integrate with the existing packet radio networks.
Good question.
Depends
I
on your
have
level.
my answer to that is this. This is your coding stick.
Okay.
The easiest solution that is we can get data in and out of this node into a Pi, and there's code available for it. Beyond that, what you do with that data is entirely up to you.
Well, for example, the Pi has an IP address and it has ports. So if your particular application uses TCP/IP, you can just attach to the Pi and ports, or you could transfer via serial, etc. It's not, or plug in a serial to USB adapter. You know, there's going to be ample ways to interface this, and we intend this as a kind of a backbone network, especially the mesh networking. But we want to provide, we're not trying to replace anything. We're just trying to give people a better option to do more interesting things that you can't do right now. Martin very strongly points out that this will do video. This will do, fast video, digital video. And he pointed out that if you decide to run this on a Raspberry Pi 5, that has native, I'm sorry, Mountain, speak up. What's the
H.264.
Yeah, it's already built in.
Mm.
So
Yeah.
into the Pi. So you just pass the signal down and let the Pi do the work.
Now, I want something else I wanted to show you as well, by the way. Speaking of the Ethernet, you may be familiar with a program called Wireshark. This is a Wireshark capture of packets that originated at my Nucleo board that were sent over to the Pi that I just showed you a minute ago. And that Pi is connected actually into an Arden node. That's where it's getting its IP address from. So the Pi's address is 10.93.13.102. This machine's IP address is over here. And I've created what's called a packet dissector using the Wireshark generic dissectors, which will take the frame apart and tell you what's in it. And so it's identified it correctly as an IP400 frame. And the from call sign. The call signs are packed. And right now I haven't been able to come up with a method of unpacking them with this dissector yet, unfortunately. And but you can see things like the number of times it's been repeated, whether it can be allowed to repeat it or not, what the current rate is, and is it an Arden node? No, it's not. Has it OFDM? No, it does have FSK. Transmit power, the firmware version is running. And in the beacon frame is position, lat long position data, which will get written into a database at the reflector. So anyway, I want to show you that work has been done, and that's on the in fact, on the groups.io that we have set up. There is in the IP400 group under files is the Pi Zero image. So you can download that today and put it on a Pi, and you'll find all the Pi related stuff on there. And on our GitHub site, there's some documentation on the SPI specification, node software, and so on. And the firmware is here. The Raspberry Pi stuff is no longer here, but the node firmwares are here as well. So there it is. Feel free to dive in, please.
So we have one of our other members is a professor at Ursinus University here locally.
Oh, good.
And very involved. He started a club at the university. He's jumped in, with the Arden stuff, and they're setting up a network across the campus. Very interested in this activity, and he's asking if, because they have he's using part of this as curriculum for his computer networking students.
Okay.
And is there some way that they could simulate the IP400 on something like Mininet or NS3 in some way, so that they could kind of do a simulator, maybe he says OFDM and mesh routing to simulate this, so that he could introduce it to the non-licensed folks?
The answer to that is the Nucleo board I showed you comes in two flavors. The CC2, which is the 430 megahertz one, which we use in the amateur world. And there's also a CC1, which runs in the 900 meg band. And all the code is on the GitHub site, feel free to dive in. And so you'll have to make a couple of minor changes to the code. So right now it's making sure that the frequency you enter is in band, but it's simple enough to change. And I believe the thing available at DigiKey.
I'm going to let Bill see if he has any follow-up questions, because we're really trying to, the STEM activities is in addition to doing the mesh network and the STEM activities that we're working with is really one of the key focuses of our group. So I'm just going to see if I can. There he is. Hey, Bill, you can actually talk. and ask your question. And
Oh,
Hey,
thanks.
Mel.
I really appreciate that. Hi, everybody. And yeah, thank you both so much for this presentation. Yeah, and I'm here virtually with my colleague, Chris Traley, who is teaching our networking class right now and invited several of our students. So we really appreciate this. Yeah, we've been using Mininet to go all the way up the protocol stack. You know, kind of introduce them to various protocols. And we happen to be talking about, you know, things like routing protocols now. We're getting into some modulation stuff later, which seems like a perfect fit for this. Yeah, that board, yeah, that it works with the in the unlicensed band, I think is a great option. And I will look into that. Maybe a quick follow-up question is, and I'm sorry that I haven't looked, so this might be easy to know, but I wonder if there's a protocol spec document that I might read, and maybe my colleague and I will try to whip up something even more immediately if there is. I had a feeling it would be right there on the GitHub. I appreciate that.
Just a minute. I don't think this is that detailed.
Oh, I see.
There's the SPI specification. It's kind of been in flux, but I'd be happy to say. Tell you what, my personal email is ve6vh@ve6vh.org.
Okay.
And you know, feel free to contact me directly, because I think there's some interesting collaborations we can do, because you probably noticed that the one thing that's missing in this whole project right now is a networking layer. Because when Steve and I talked about it earlier, we said, okay, we'll put that on the Pi and we'll do that later. I mean, we've only been doing this for 3 months.
Right.
And
True-
in
true
3
dat.
months, we've gone from 0 to Pi 0. And there's tons that can be done. So I welcome any kind of collaboration. I've been looking at things like Babel and what the one they use on the ARC network.
OLSR.
OLSR, yes.
Mhm.
And the one that uses there's another one out there as well.
Well, they're converting to Babel, which is seems ideal for IP400 because of the lower bandwidth. And Babel is a lot less chatty than OLSR. And
So here, yep.
yeah, and
Well,
you know,
the groundwork has been done. I mean, the frame does contain routing information in it when it's received. What it basically did is, like, any station can repeat a frame if the flag is set in the frame to say I'm repeatable. And so it does it. It adds one little hop count, and then it puts its call sign into what I call a hop table, and then sends the frame on. So when somebody receives it, they've got all the routing information of how that frame got from point A to point B. But going backwards, I haven't really got as far as how do we do something like, let's say, I want to send this frame to Steve. I know Steve's call sign. I have no idea how to get it there. And how do we do that? And how do we, what's the best place for that table? Is it in the node? Is it in the Pi connected to the node? It has more memory. Or is it a server based? Don't know yet.
I should rewind, and something I should have emphasized in this presentation, but I neglected to say it specifically. Every bit of this, you know, all of the software, the protocol, everything, that's going to be open source. You
Yes.
know, no secrets, nothing proprietary. This is an amateur radio project for amateur radio users. Martin and I know that we're not going to be able to figure all of this out, you know, and present it as a fait accompli. You know, this is going to be a forever work in progress, and we fully expect it to get forked, you know, and you know, other interesting things happen to it, and can't wait. You know, so Martin has done a fantastic job of documenting and kudos to Martin, because he's not a typical software developer, because he's been through the school of hard knocks as a manager, And so Martin has documented as he's gone, gone along, which endears him to me because he gives me things I can read.
Mhm.
So um,
I
it's
found that the value of good documentation a long time ago.
oh yeah, yeah, absolutely. Well, most
Yeah.
developers don't learn that lesson, you know. So
No, it's
they'll,
like,
they'll
oh, why do you need comments and see? It's
right, yeah,
self-documented.
why, isn't the source code good enough? So yes, so
I
there's ample documentation, and there's more detailed documentation than what Martin has chosen to expose publicly that I've been privy to, and blows me away. So there's
Yeah,
we're
there is another repo which is private,
yeah, so
where I put all the pre-release stuff,
yeah,
and it's open to a select few.
yep,
And as I said, send me your email, and I'll be happy to add you to that. And you can,
yeah.
but
I
just check with me before you put anything into the public domain.
Bill, I took a quick glance at the chat, and there's a few questions queued up. So could we? I don't want to short anybody, and we
Yeah,
are
there's I'm just going back and looking at the ones that we haven't. I've tried to kind of put a few together. There was an early on question that we didn't discuss, which was um, the resistance that might be coming from folks who are, I don't want to, anti-digital modes. There's the FT8 hate crowd, that kind of thing. And have you guys bumped into that, and how you're planning on maybe?
oh, that this happens to me all the time in
Yeah,
zero retries. Well, I don't do digital modes, and that's fine. It's a big hobby. We've got plenty
yeah,
of spectrum. Do what you like, for goodness sake, we're not trying to force this down anyone's throat. We're trying to give people that, and frankly, I'm okay. So I have been accused of being elitist in this particular perspective that I'm about to espouse. Um, but I'm aiming all of the work that I do um, in zero retries at the generations that are coming and the folks like me and Steve that want to play along because it's fascinating. It keeps the brain cells moving, in at our generation. Um, so but I really, if we're going to have amateur radio in another hell 10 years, we better be offering them something that is more interesting to them than sitting, the image of Herman Munster sitting in the basement tapping on a Morse code key, which is an incredibly robust meme that just keeps coming around every time amateur radio. Every time I see a story about amateur radio, in social media, sooner or later that meme gets posted. Um, oh, I just saw a message pop up. No, Martin and I aren't don't quite have enough bandwidth to keep up with Discord. We welcome their a Discord, activity, but it ain't the two of us. Um, so
We have
maybe
a groups.io. You're welcome to join it.
Martin's a little less sympathetic about that question than I am. But Martin stays busy all day on IP400. I do a few other things. So I'm sympathetic to it, and I have tried to stay up on Discord, and I've confessed that I don't have the bandwidth. So
Actually, there was also an earlier question about using large language models to generate some of the code, and have you guys thought about doing that to help out a bit?
we have not, because this is the really low level stuff. And
Yeah, yeah.
we have to figure out the concepts first to tell it, how to do what we want to do. But absolutely, I am absolutely convinced that that's going to happen. And you're basically going to point a LLM at the IP400 spec, pointed at the the manual for a GNU radio, or sorry, a software defined transceiver, and say, I want to do this on that, and you keep iterating, and it's going to happen. What is it called? Vibe coding is a real thing now. for that sort of
Mm.
thing. But
Mhm.
no, you have to have a working model to work against
Right.
before you can go to that extent. But yeah, absolutely, it's going to happen. No question. Um,
Good.
let's
Looking
see.
to see if there's anything else that got missed. A lot of folks are saying a couple of folks are saying they have joined up with just waiting approval for the group's IO.
I just approved 4 of them.
There you go. I'll be doing mine afterwards. I'm busy right at the moment.
Well, Steve gets them too, so we're both
Yeah.
admins on that.
Yep.
Oh, there we go. Good.
Uh,
Oh, says thank you. Ralph says thank you.
okay.
Yeah, just reach out to Bill. Go ahead and send me your email, and I'll send you
Oh,
some more documentation.
I saw another question that I wanted to answer and say a quick hi to Cale Muth. And Cale edits the fantastic Amateur Radio Daily and Amateur Radio Weekly newsletters. And he asked if you're going to be able to use this. Sorry. I apologize. I munged the question, but no, you're going to have to initially, at least, you're going to have an IP400 module plus the Raspberry Pi to plug into your laptop. But I expect that when you do that, and you're going to have to give it its own power supply, I think. But then
It's power supply is contained on the IP400 module board.
yes, I understand. But you're going to have to power it independently of the laptop.
Yeah,
So that
and it's Wi-Fi right now.
It's Wi-Fi right now, but you should be able to plug in your laptop with a USB adapter and then get the equivalent of an Ethernet or a serial connection to it. So here's one of my many usage scenarios for IP400. I hope we can get the price down where it's really attractive to a college student, that they're going to put it in their dorm window and they will then have a private amateur network that they can, that's completely decentralized, independent of everything else. You can attach to it with Wi-Fi or Bluetooth, and you just work IP400 on your laptop or your phone or your tablet or whatever, and do all the things that you're used to doing, chat, email, exchange videos, including live video. That all that stuff is, we're fine. We're really truly bringing, in my opinion, we're bringing amateur radio data capability into the 21st century. And we've been doing half measures for 20 years now by using more and more sophisticated modems, including what my admiration for the Vara FM capability. That's basically just a really sophisticated modem, but not really improving at the radio layer. This is operating at the radio layer. This is a digital radio. No modems, no analog stages, no place to plug in a microphone.
Mm.
If you want to talk, you're going to be talking through your laptop as a digital stream into this radio, and it will be transporting it, and then it'll unpack it on the other end as an audio stream.
Mhm.
So
By the way, Vera FM is actually audio band OFDM.
yes, exactly.
Mm.
I had that in the slide deck. It's pretty condensed from where I started. I've been working on this thing for 3 days, and that was one of the points I took out. Was that we've been doing OFDM for a long time. We're just doing it in the audio realm, and so now we're doing it in the radio realm.
Yeah.
Well, I built my first OFDM transceiver, which is behind just above the bird watt meter there, hanging on the wall, in 1996.
Mm-hmm.
That was 26 megabits a second.
Nice. I'm surprised that we haven't gotten any questions around Meshtastic, because they seem to always pop up in these types of discussions.
I did cite Meshtastic as evidence that there is intense interest in doing this sort of stuff.
Right.
And Meshtastic is a lower barrier to entry. And quite frankly, we don't have a good answer. We don't have a good alternative to Meshtastic in amateur radio. For a while, I was starting to cite the messaging capability in APRS until I learned just how
Yeah.
Constrained it is.
less optimized than it should be. I'll just put it that way.
Very constrained. Martin just joined your Alberta Digital Radio Communication Society.
Yeah, I put the link to the our website in there as well.
Yeah.
I apologize. I should have also offered that. If you want to support IP400 directly right now, prior to us releasing any hardware, yeah, that's the way to do it. Join ADRCS. They are sponsoring this project. If we do get a grant, it's going to go through ADRCS. And again, that was one of the factors that I regarded made this project viable, was the fact that, that legwork was already done and we did not have to create that from scratch. Oh, there was another question that I saw, that what makes this a minimum viable product rather than just a minimum product?
Yes.
And viable is the fact that it will run 100 kilobits per second out of the, from the beginning. It will run, it will have mesh networking built into it. You will be doing things with this system that you can't do with any other system. In the aggregate, it will do a combination of things that does not exist in other systems. Again, Martin and I are both fans of Arden, but unless you can do microwave, unless you live in a great place to do microwave, it's not much of an option for you. This is going to be on 400 megahertz. You can do mesh networking in Arden, again, on microwave. You're going to be doing mesh networking on 400 megahertz. You can do 100 kilobits per second on various other systems, wider channel than what we're going to require, et cetera. So we think this is a unique combination of capabilities and features that we're going to implement in amateur radio spectrum, and amateur radio spectrum that is unique to amateur radio, well, relatively unique to amateur radio. 400 megahertz band, truth be told, in the US is a shared band. We're secondary allocation, but the primary tenants are very nice to us. So don't give us any grief most of the time. Unlike, for example, 902 to 928, where the Part 15 folks are just really rambunctious.
Yeah, exactly. Well, let's see.
Hey, is it time to wrap up?
Yeah, I think so. I'm just seeing there's not any more, but I would just say that I think at peak we had somewhere close to about 75 attendees on this.
Cool.
So a lot of interest, and we still have, about 43 folks hanging in there to the very end. So I think that's an indication of how interested people might be in this particular activity. And thank you very, very much for taking the time.
I'd be interested in a very short straw poll. How many are planning to go to Dayton?
Steve?
Yeah.
I'm not going to be able to make it.
You and I are having dinner.
A lot of folks are starting this. It's going to be looks like there's going to be a pretty good crowd.
Yeah.
Good.
Okay.
We'll have multiple chats in the 2.5 days of Dayton. I'm quite. Is Martin going to be there?
Well,
They're going to let you cross the border, Martin. Is that the problem?
that's the issue.
Yeah, I was kind of halfway kidding.
Despite the fact I have a Nexus card, I have a TN visa to work in the States, and I have security clearance, it still could be an issue.
Yeah. Regrettably so.
Yes, much. Yeah.
But if you're there, we'll have a chat.
Put it out this way. I'll be there in spirit.
Well, I will be at Hamvention all 3 days. And I'm sworn to secrecy still, Martin. Yes. Okay. All right. So anyway,
Well, actually,
there will
I
be an
put a
announcement.
post on, yeah, I put a post on our forum. Our biggest issue, and you were on the call this morning, you
Yeah.
know the issues we're dealing with. It's
Yes.
really nothing to do with development at this point. It's more how do we get these things in your hands
Yeah.
of an
The,
issue is
the,
what we're dealing with right now. So we don't want to really let any cats out of any bags until we're absolutely sure that if there is a pent up demand, we'll be able to fill it. That's the big issue right now. So we're hoping to make an announcement in a couple of weeks that all those roadblocks have been removed.
I will be at Hamvention, and it looks likely that I will be able to be at a stable place during Hamvention where people can find me. That announcement will be made on May 2nd in Zero Retries 0200. With the details of that, but right now we don't have something to say. And my wife Tina, who's also watching, says invite people to contact you with questions that do not get answered, especially the teachers. Get their contact info. So you have my email address. Again, it's really easy, steve.stroh@gmail.com. And I'm happy to talk to anybody about IP400, especially about the digital conference. The digital conference, unfortunately, is only like 3 weeks old. So we don't have exact things nailed down yet quite, but Tina is awesome at logistics, as I've seen, in the previous 2 conferences. So it will be a blowout event. So please reach out directly. And if you have questions about that or anything I write or anything about zero retries, please, if you like what you heard tonight, you'll probably like zero retries, at least most of it. And there, as I just published zero retries 0198, which means there's more than 200 back issues available for reading. I just discovered an awesome capability today that will let me do video tutorials, short video tutorials as presentations. So look for those. And eventually there will be the Zero Retries YouTube channel. That's on the short list, but mostly I'm working on Hamvention right now and keeping the cadence of Zero Retries going. So any last...
Thank you, Steve. And thank you, Martin, for joining us.
My pleasure. Always happy to spread the word.
And thanks to all the managers at the Jim Fisher Memorial Digital Network Association for supporting us in going forward with this webinar. And most of all, Steve, thank you for a fabulous evening full of information and the excitement that the 12-year-old me still losing at age 75. Thank you all so much.
Yeah.
And
Thank you,
Bill,
Dave.
my teammate and partner in this effort, never could have gotten here without you, but Steve talks about Martin as the man who walks the talk. Here's the man who walks the talk for us. Thanks.
Thanks, Steve. Well, and everybody, the slides and the presentation, as soon as Zoom is done doing its AI stuff on it and generating all the transcripts and everything, so I'll be posting it probably sometime tomorrow on YouTube and on it'll be you can find us. You just search for JFM DNA on YouTube. You should find us, as well as a link will be on the JFM DNA website jfmdna.org. So,
And I'm happy to publicize it on Zero Retries also this coming Friday.
yeah, and I know you put the link in your announcement, I think, so you can do it again for the video, I guess. Yeah.
Yep.
Great. Thank you again, guys. Good night.
7-3 all. And Bill and Steve, thank you very much for inviting me. This was some of the most fun I've had in a good long time. So thank you for asking.
And that ham radio is supposed to be fun, isn't it?
It is.
Oh, work. Come on, guys.
Yeah.
Okay.
All right.
Okay.
Tell my
Okay,
wife
night.
about that.
7-3 all.
7-3, guys.
Good night.
Good night, everybody. 7-3.